Hello, Tungsten Miner here. I thought today I'd talk about big reactors, and specifically this big reactor right here. So I've mentioned it a couple of times in different videos that I get my extra boost of power from this thing, and I've got it set up so that it only comes on when I actually need it. Well, how does it work? What does it do, and how did I make it? So having walked all the way around, you can see it's kind of a big box made out of lots of different customized sort of bricks and blocks and things. And it's a giant big multi-block structure. The basic elements are this controller, which when I click on it gives me the interface to the reactor itself. In this case, the reactor is telling me that it's currently very cool. It's not running. Its casing is very cool, because of course it's not running. It's full of fuel, and this 0.8% depleted means that that percentage of my fuel internally has been converted into waste from the active fuel. And so you can see down below that the number of fuel rods times the maximum capacity gives me so many millibuckets, or 60 buckets worth of liquid fuel, and then 59 point something buckets worth of that is actually still active and can produce energy. And then I've got about half a bucket worth of waste. And where all this kind of comes into play is the next two items to know about. One is the inlet in green and the outlet in blue. The inlet has a spot for up to 64 Yellorium ingots, or whatever you're using for fuel. I'm using Yellorium. There are other things. And over here, I've got my outlet. And at the moment, there's nothing in there because I've got a pipe system that draws it out immediately. But I can choose to eject fuel or eject waste. I can choose to put it in inlet or outlet mode, because basically it's the same block, whichever way. Around the back side here, I've got this reactor power tap, which just outputs power. And around the side here, although you can't see it, that block behind there is a computer port, which allows me to plug in an adapter from OpenComputers that goes back to this computer setup over here. So that's the basic gist of things. Just to talk about some recipes here. The reactor casing itself is just this guy. You've got some iron, you've got some Yellorium, you've got some graphite being produced by just taking some coal and tossing it into a furnace, and that gives you a graphite bar. You can use the reactor casing then to make most of the other parts that you care about for your reactor. So this is your reactor controller, this is your power tap, this is your access port, this is the coolant port. So there's a couple of different kinds of reactors. Some of them use the coolant ports. I'll talk about that in a little while. Here's your control rod that goes on the top. Your computer port. The cyanate reprocessor is a different machine that you can use to reprocess the fuel. And the redstone port allows you to turn on and off your reactor based upon a redstone signal instead of a computer signal. And reactor glass, which you use for the sides of the reactor. So I'm going to take this guy apart a little bit, and I'll be back in a minute so you can kind of see how it works internally. Okay, so here I am standing on top of the partly disassembled top of the reactor. And what we're looking at are, I'm standing on the very edge of the corner here, and that's just a reactor casing block. I've got some reactor glass forming the side, that's the controller down there. Over here I've got my two input ports, and again buried down in the glass. And right here is a Yellorium fuel rod. Now this starts out empty, but because this reactor's been running, I've got some fuel in there and gives it that yellow color. There's actually a stack of 3 of these things underneath, going all the way down to the bottom of the reactor. And underneath is just more reactor casing blocks down there. This stuff here is actually liquid Enderium. It's what you get when you take ender pearls and run them through a magma crucible. This mod produces RF and requires thermal expansion as it's, the RF core stuff. So no surprise that they rely on the machines from that mod to be able to make the various components. Now the significance of using this is that your reactor, when it gets hotter, becomes less fuel efficient. It burns through fuel more quickly. So if you want to be able to produce lots of energy without requiring lots of fuel, you need to have some way to cool down the internals of the reactor. And it just so happens that this material, this liquid, is the most efficient coolant that you can use for your reactor. So I've got 1, 2, 3 times 4 stacks of this stuff in here. And that's what gives me my coolant. Now I could work without coolant, but there's a danger that I'll get to peak temperature and it will start to get very, very inefficient, burn through fuel really quickly. One thing I'm pretty sure is true, and I think I've seen this documented in places, that you can't actually cause these things to explode. That would make a really ridiculous explosion considering how powerful they are. But I don't think that's actually possible. So I've got my pattern of reactor fuel rods, so 3 tall, and there's a pattern of 5, and you can see the remaining control rods at the top with the little white dots. And the control rods allow you to move a kind of neutral substance down into the reactor core to prevent it from producing energy. So right now, this control rod is inserted all the way down, which means no energy is being produced by this stack of fuel rod underneath. If I were to change this to make it not at the bottom, I'm now producing power. Now I actually do have a computer system hooked up to this, so every 10 seconds the computer scans all the control rods, scans the energy requirements, and sets the control rods back to where they should be. So even if I go and mess with this, the computer is going to wake up in a couple of seconds, notice that things are not where they should be, and then move everything back to their proper locations. There it goes. So I'm going to put this guy back together by dropping those guys back on, and I'm going to, if I can get this right, put my reactor casing blocks back in place. And you can see the controller is dark right now because this is now just a pile of blocks. It's not the multi-block reactor because it's missing that spot. So it's only once you've placed your final block that the textures all change and this guy wakes up again. So I'm going to turn him back on, and he's warming himself back up again. Yep. And soon enough, the computer will take over and set things back to rights again. So I'm not too worried about him. So how do you get all the materials you need to build this stuff? Well, iron, obviously, getting some coal for making the graphite is fine, but Yellorium is in this mod pack configured so that it only appears in places where uranium would normally appear in the real world. So in this case, in the desert, buried in sandstone, and actually under the ocean is the other big place. So that's where you get all the materials for putting this together. Next, let's talk about the various kinds of reactors. This is an example of the simplest kind of reactor. Now, it's bigger than the simplest possible reactor, but it is what's called a passive reactor. So there's nothing causing, or passive cooled reactor. There's nothing causing this reactor to get cooler. We're not pumping some kind of coolant through the reactor and then taking the heat and doing something else with it somewhere else. So any heat that this thing generates just has to dissipate, I guess, through the outer shell. Now, I don't have one of the actively cooled reactors, but that's where that coolant port comes in. And what you generally do is you'd have a coolant port where you build the reactor the same way and pump in water or something else as a coolant, which will then get hot, and you have to pump it back out again and run it through something that's going to cool it down. If you're going to take big reactors to its fullest extent, what you'll wind up doing is pumping in water, having that get converted to steam, which you then take out through the opposite coolant port, and when it comes out, running it through something that requires steam. So for example, there's a bunch of the steam engine type things that come from railcraft, and you can run it through one of the big furnaces that require steam from railcraft. Or you can run it through a big reactor's turbine, which is basically a huge fan that you push steam through and it causes the blades to turn and generates power that way. The turbine actually generates a lot more power than something like this does. even though something like this generates still quite a lot of power. But you can then use the two in tandem. So you've got your big reactor that generates power and steam. You've got the steam that goes into the turbine, which generates even a lot more power. And the steam going through the turbine cools to water, which you then cycle back around to go through the turbine. So it's kind of a way of amplifying how much power you can get from one unit of fuel, because you capture a lot of the waste energy that normally is getting shed through the skin of the reactor in the form of steam. And you send that steam off to some place where it can do even more work for you before getting turned back into water. All right, so let's take a look at this computer control system a little bit. This is the main screen, and this is a little program that I wrote for myself in Lua using OpenComputers. So what it's showing me is that the reactor's turned on. This is how much power is in its internal capacitor. This is a bug. That shouldn't be 0.0, so I have to go figure that out. This is telling me it's currently producing no power at all, and it's got as much fuel as it has in there, which is nearly full. And then it's reading off the list of control rods and telling me what position their control rod is in. So 100% means the rod is all the way down, preventing all reactivity in the reactor. So 100% means 0% power production. And this last one being at 99.5, well, my program uses decimal numbers, but the control rod uses integers. And so this 99.5, when you tell the control rod to go there, actually winds up being 100%. So the program's reporting things a little bit differently than is actually going on. We actually can stop the program and take a look at how it works. So let me do that. Okay, so I've stopped my program. And this uses standard Unix-style commands. Yeah, so there's nothing here. User bin. I'm also using one of the slowest computers in OpenComputers, and so it artificially slows way down all of its operations. Okay, so here's the actual program. I'm going to walk through this very rapidly and not get too much into the programming, because this isn't something that most people want to get into. But if you're a programmer, you should probably recognize a lot of what's going on here. So these first couple of things, there's some code that's already written that you can reuse, and that's what I'm doing here with all these requires, is using some stuff that's already built into the computer. And then I'm going to say, hey, if this reactor is not available, like if it's not plugged in or something, then I'm just going to print a message saying, hey, there's no reactor, and then stop running. Then I'm going to go get myself a reference to the reactor itself. I'm going to set up a bunch of values that I care about. So I know it just so happens that the reactor has 10 million RF capacity, and I know that the smallest amount of energy that I want to have available in the battery is this much. And the amount of energy that I do want to have is this much. So it's the maximum times 5% and the maximum times 95%. So I want to keep the battery internally somewhere in that range. And then these other two things are just keeping track of some values that I'll need. So while true, do means repeat the next piece of code forever, because true is always going to be true. And then I'm going to say, okay, figure out how much energy is stored right now. And if things are inactive at the moment and the stored energy is less than my minimum, then turn it on. And if the mode is active and the stored energy is greater than the maximum, then turn it off. So I'm keeping track of whether I'm trying to produce power or I'm not trying to produce power. And I'm going to keep going until I get over the threshold of the next set. So if I've gotten below that minimum energy, just because I've produced enough power to be above the minimum doesn't mean I want to turn the reactor off yet. I want to get all the way back up to above the maximum before I turn the thing off. And then if I'm in mode active and I have no energy stored at all, then I'm going to set the percent to 0. And otherwise, I'm going to set the percent to the amount stored divided by the desired energy. So this is the percentage on I want the machine to be right now. And otherwise, if I'm not in active mode, then I want percentage to be 100%. So that's where I want the control rods to wind up. Now I'm going to read how many control rods do I have so my program can work no matter how I've got my machine configured. And then I'm going to figure out where do I want the first control rod to get set to. So I'm going to clear my terminal. I'm going to print out a bunch of stuff. So this is all the stuff you see on the screen when you're just watching it. And then I'm going to walk down through all of the control rods and try to set each one to the right value. So I'm going to figure out if the control value is more than 100%, then that means I've got enough power demand where I need to have one rod at least completely open so that it's generating as much power as that one fuel rod can generate. And then I'm going to open up another rod if I need to. So I basically say, how much power do I want to generate? How far down has that battery been depleted? And whatever percentage it's been depleted, that's the percentage I want to open up the control rods. So as it gets more and more depleted, I open up the control rods further and further so that eventually the control rods get opened up to produce just as much power as I'm using. Now I know I'm using these gold kinesis pipes from Buildcraft, and I know that they can transmit 2,500 RF per tick. So I know that's the limit. Now, I didn't want to write my program with that in mind. I want the program to be adaptable so that if I upgrade my pipe system, it just smoothly says, oh, okay, we're using more power. We'll keep opening those control rods. Otherwise, if the control rod percent is 0, then I'm going to set the rod percent to 0, because that means I want it all the way open. And if the rod percent is equal to the control, otherwise I'm just going to set the rod percent to whatever's left. So basically I'm saying I'm going to take off 100% at a time from the target value. And I'm going to open up a control rod all the way to match that 100%. And I'm going to do the next one, and the next one, and the next one, until I've got less than 100% left. At which point I'm going to say, make that control rod open by the amount that I have left. So, for example, if I said, oh, I have 50% power remaining. I've got 5 control rods. They each have 100%. So I've got 500% total capacity. Since my battery is depleted by half, I want to use half of that capacity. So I need 250% worth of control bars opened. So I'm going to go to the first one and say, open that one 100%. That means I've got 150% left to open somewhere. So I go to the second one and I say, open that one 100%. Now I've got 50% left to open. I go to the third one, I say, open that one 50%, and now I've got nothing left. So I've opened every control rod as much as I need to. So that's how this logic works, is it's going to open up control rods one by one as far as it has to get to the total amount open it needs to get to. And then this last little bit of code down here is actually doing the setting of the control rod to the right values and printing out what I set it to. And at the very last thing here, I'm going to say sleep, which means don't do anything for this long, so 10 seconds in this case. And that's it. That's how the whole program works. And I'm going to close this editor, and I'm going to run this program. And now it's turned back on, and it's ready and watching again and ready to go. So that's how I keep the control rod, I keep the reactor running and have it produce only so much power as I actually require. Because you burn less fuel, you run more efficiently the smaller the amount of power that you generate, because it keeps the heat down. So where do I get this fuel from? Well, I've got a big bucket of it over here, and just to get started with, I actually just went and dug a mine and started finding some Yellorium a little bit at a time in order to get things powered. But you also notice I've got these very handy Yellorium drones. And these guys come from Binnie's mods, which is an extension to Forestcraft. Forestry, not Forestcraft. So forestry allows you to breed bees together in order to produce different species that produce certain outputs. So in this case, I've got these Yellorium bees, and they produce combs every once in a while that produce these Yellorium grains. And if you combine 4 of these things together, you get Yellorium dust, which you can then smelt into Yellorium ingots. So I've got a whole setup of bees outside. Let's go take a look at the beehive out there. that all produce these Yellorium combs. Now, they don't produce them very often, and the combs themselves don't even necessarily always produce a Yellorium grain. So this is a very time-consuming process that accumulates fuel very, very slowly. So I've got actually 7 of these things, and in my apiary I've got my Yellorium queen and a set of Yellorium drones. I've got some pipes down here which cause the process to get automated. I'll talk about that when I talk about forestry a bit. But the important thing is that all these pipes ultimately lead back inside to the bottom part of my reactor building. So when we go back inside and take a look, we can see over here that the pipe coming in is right here. So the first thing that's going to happen is, let's talk a little bit about thermodynamics and the piping systems. Thermodynamics has a fantastic pipe system that's very, very powerful, and you can do a whole lot of interesting things with it. But with that comes a little bit of complexity, so you kind of have to figure out what you're doing. What we're watching here is various byproducts from the bee breeding process coming in from the outside. So we've got some drones coming in. Drones are produced whenever a queen dies. She'll produce another princess, and then that will produce some drones as well. And oftentimes combs come along with that, but I don't see any coming at the moment, so maybe we'll see some soon. In any case, this blue widget here is a filter, and the pipe has connected to the top of the centrifuge, and the filter prevents anything except the right blocks, or the right items, from going down inside of it. So you right-click on it, you can see I've got a whitelist saying only these things, which allows barren combs and Yellorium combs, the 2 types of combs that are produced by my bees, to go into the centrifuge. So there's a comb that went through, it just got turned into beeswax. This thing is a servo, and it just causes anything in the inventory of the block attached to it to get spit out into the tube system. Oh, here comes another comb, that one's going to get through the filter, and in it goes. With all of these item ducts, the items are going to go from whatever the source place is, what is source inventory, and they're going to scan the entire network and look for the nearest inventory that can accept them, which is why it's important to have these filters, because I don't want the extra drones going into the centrifuge. They'll just clog up the works. What I want instead is for the drones to go all the way down the system here to this box where they get collected. And as you can see from that little teeny purple star, that's a void upgrade, which means that it's going to destroy any items in excess of what this drawer can hold. Now, I've been running this for a long time, so it's long since past the point where the wax and the honey and the drones have built up to be at full capacity. So they're all getting destroyed at this point, every single one that comes in. And all of these things you can see have filters on them, even over here. These 2 are a little different, so I'll talk about those in a minute. But they all have filters to prevent the wrong sort of item from getting into the wrong machine and gumming up the works. This machine is a cyclic assembler, which uses a schematic, a recipe, to create... can I show it off again? No, it looks like that. Which uses a schematic to specify a recipe. And you do that by dropping an empty schematic here, and then filling out the recipe like you normally would, and clicking this button to print the schematic. And from that point forward, you've got a little item that can tell this machine what to do. As I press the sneak key, shift in my case, it shows me exactly what the recipe is going to produce, and I can just hover over it to see. So I need 4 Yellorium grains, and it's going to produce 1 Yellorium dust. But it's going to do so automatically, and I don't have to mess around with it or be here for that to happen. It just goes on its own. So this filter is going to say only Yellorium grains can go in here, which are one of the things that can get produced from the centrifuge. Next, this servo is going to spit everything back out again and up into the pipe system. This filter is looking for Yellorium dust, which of course is the output from this guy. And so Yellorium dust comes out, goes up, drops into here because it's the nearest inventory where it can fit. This is just a plain old furnace that's run by redstone flux power. It's going to produce a Yellorium ingot, and this guy, the drawer controller, is the one block in the storage drawers mod that allows you to pipe inputs into it, and only into this face, so you have to be a little careful in arranging things. This filter, of course, is set up so that it does not allow, uses a blacklist instead of a whitelist, to prohibit these combs from coming in here. Technically, that shouldn't be a problem because they're going to want to go in here anyway, but if for some reason the system gets backed up or something weird happens, that'll prevent combs from getting stuffed into this drawer and making a mess of things. Once it's in the drawer, I now got my Yellorium ingots in here. So how do they get out and back into the machine? Well, over here, of course, I've got my access port, which is set into the inlet mode, and therefore has a bunch of Yellorium ingots in it. And I've got what's called a retriever. A retriever is another filter-like item. So it's like filters and like servos, except it's going to put out a kind of request into whatever storage network, whatever pipe network it's connected to, and say any inventory who has this item or these items, send them to me now. And it will actually pull things out of the inventory selectively, just the ones that you're asking for. So in this case, I've got a whitelist and I'm asking for Yellorium ingots. So whatever this thing is connected to, if that inventory has more space in it at all, it's going to make a request to its network and draw something out of the appropriate inventory to stick it in here. Needless to say, this is happening pretty frequently if you have a lot of these going, especially in a server environment, and especially if you have a really big storage network. This gets super, super, super slow. So don't use these on a big network. Set yourself up so you have a system like this where there's a very small network that's got an intermediate place where things get dropped, and then have the retriever have one or two pieces of pipe to talk to just the one inventory in order to keep things from getting too bogged down. Suffice to say, though, I've now got a big supply of Yellorium ingots, and I've got a way to automatically suck them out and drop them into the reactor whenever it uses up one of its pieces of fuel. Now, of course, the way this works is as the temperature rises and we start producing more power, we're going to burn through that fuel. And you'll see a little bluish smear start forming on, I think, the bottom of this indicator. And when it gets all the way up to 100%, since I have auto eject waste turned on, it's going to look for an outlet reactor port in which to drop it. So it'll form a cyanite ingot, which is the output ingot, and drop it into that automatically. Now, I just so happen to have an outlet mode port over here, and so it will drop it into this inventory. Now, I've got another servo here, which is going to pull out anything that's in that inventory. So it's got a blacklist, and nothing's blacklisted, so everything. And then it's going to spit it out into this pipe system. And of course, the nearest thing that it can accept cyanite is right here. So I wind up dropping all of my output into this drawer. And there are various things the mod allows you to do with the cyanite. So for example, you can reprocess it into a more powerful kind of fuel. You can use it to build parts for your turbine. You can, well, actually, I think that's about it. So those are the two things you can do with it. But it's not wasted stuff. You can still use it for other things. In any case, though, that gives you the complete system. I showed before how it gets activated is when this box gets empty, this chip is going to switch the pipe signals. The pipe signals come down to a gate. They allow power to be drawn off through the pipes. That sucks the power out of here. Around here we can see this is going to start dipping further and further and further down until it gets below a certain threshold, which causes the computer to wake up and say, oh, too little power. I'm going to start turning on these control rods piece by piece in order to allow the power plant to start producing power. The fuel is going to start getting used up, and when finally there's enough of it used up, it's going to auto-eject the waste into the access port. That's going to go over here. At the same time, it's going to use up one of the Yellorium ingots here, leaving an empty spot in this inventory. The retriever is going to put out a request, which will go around and pull more fuel from the box that I've got over here, which gets replenished by this processing of Yellorium combs coming from my bees outside. And that's it. That's my whole big reactor setup. So, as always, if I skipped over something or there's something else you want to ask about, go ahead and leave those comments. If you like what you see, go ahead and hit the like button on the video and subscribe to the channel to see more. Talk to you later.